Hi, welcome to an Arduino tutorial from Robojax. My name is Ahmad Shamshiri. In this tutorial, I'm going to show you how to implement the overcurrent protection for Winson WCS Current sensor and implement it using Robojax WCS library to disconnect the current when it reaches certain value. We're going to use a relay, and this will be implemented with the LCD and without the LCD. Doesn't matter which sensor you have. You can have this type of sensor without a PCB with a hole through, or you have this shape of sensor that will pass hole through, or maybe a module, something like this, that a 2-wire will be connected here, which I'm going to show you, or this module, or this type with the 2 terminal on the side, or if you have something like this, or something like this. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. This is a detailed video where people will learn. If you don't want to learn and just grab the code and run it, the link for the code is below the video in the description. Overcurrent protection is used in many applications, in battery charging or for current monitoring in different applications. And I'm using Robojax WCS library for Winson WCS Current sensors. The library that I've written will work to read the current from any WCS current sensor. This is just an example, and you can simply select the model that you have and the code will work for it. I have separate video and introduction for that. Also, I have separate video how to display the current when you measure it, display it on an LCD. This is only for overcurrent protection. I'm not going to explain all the specification of the sensors and how they have been implemented, because I've already spoken about those in a separate video. This video is just to implement and make this work. In order for the project to be successful for you, please watch that introduction video for WCS current sensor and make sure that you are able to display the current on a serial monitor. After that, also watch another video that I've implemented to display the current on a LCD. And after that, then come to this video. For the LCD, you don't need separate library. I have incorporated the LCD library with the Robojax WCS current sensor. So I've made it very simple. This module needs 5 volts, and the LCD also needs 5 volts. The relay needs 5 volts. Because this needs about 3 milliampere and this needs about, I've used the digital pins as a VCC for this, so this gets the power from pin 8, and also for this one I've implemented pin 9 to supply 5 volts for this, because I wanted to leave the 5 volts empty for relay, because relay needs about 80 milliampere, and Arduino digital pins cannot supply it. But of course, if you need to use the digital pins, these digital pins for something else, you can do so and supply direct 5 volts for these modules. That's also okay. So how it works is that we are connecting the power and it passes through the current sensor. Doesn't matter this type or many other types of the current sensors that we have with the WCS. The current reaches that threshold value that you set in the code. You will also set the time, how long it should wait. So once it detects the current, it will disconnect. But you cannot simply just disconnect it and then continue like that, because the current will be immediately 0 and this will reconnect it back. So to prevent that, I've implemented 2 methods. First, we will keep it waiting, let's say for 5 seconds, 10 seconds, whatever time you set, and it will wait and then reconnect. This will be useful for some people, but in some applications, when the current reaches certain value, you don't want the load to be ever connected again. So you have to disconnect it and keep waiting indefinitely until somebody comes and checks it. You can do that also in code very easily, to wait or not wait forever. Another important factor that you need to know about the relay is that the current rating of the relay that can control is, for this relay, is 10 ampere, and also you can implement this type of relay doesn't matter which module you use, but these are 10 ampere. If you want to control higher current, there is this type of relay that I found on Amazon and eBay. This is 80 ampere. What it means is that the load that you're connecting from this cable, it will come through this relay. This is 80 ampere and it can handle 80 ampere. If you're using above 80 ampere, let's say 100 ampere type sensor or 200, you can implement 2 or 3 of these in parallel to make 2 times 80, 2 times 80, 160, or 3 times 8, 240, and so forth. You can connect these in parallel to increase the current. I will try to make a separate video connecting all these relays in parallel to increase the current. If you connect 2 relays in parallel, it will be 20 ampere. You can increase the double it, and if you put 3 of this, it will be triple, and so forth. And let me talk about these 2 relays. This is a high trigger relay, meaning input signal at this pin, this S signal, when it receives anything above 2.5 volts, it will turn on. When it receives below that, it will turn off. So it's high trigger with high voltage. But this one at this pin, when it receives anything above 2.5 volts, it will turn off. And when it receives below that, it will turn on. So this is called low trigger. This has an LED here. When it has power, it will be turned on. When it receives the signal, the green will turn on this, and this relay will energize and disconnect or connect. But this one has only this LED, and this will turn on only when it receives the signal. For these pins, we have this is normally open, and this is also normally open. Middle is common. The last pin is normally closed. So in this one, we are using it between common and normally closed because we want the load to be connected all the time except when the load increases. And in this one, we will connect it between these 2 because the signal will be always at the input, and this will always have some low signal and it will be on. So we have to connect it at normally open, so this will be always on and will be disconnected when it receives the signal. Keep in mind that this one needs continuously 80 milliampere to operate, and it consumes energy, and it will stop using energy when the signal, when the current reaches above threshold value. When it disconnects the current, then the relay will be turned off. So this uses some energy while in normal operation. This is the opposite. In normal operation, it doesn't use energy. The current passes through, but when it receives the signal and when the current is above the threshold value, this will just energize and consume energy to disconnect the load. So these 2 are opposite of each other. This is not a desired method in case if energy is your concern. If not, that's okay. So here you will connect your sensor, load, and relay, either something like that. You can connect it the positive and the positive line, or you can combine them between positive and negative. I will provide you all these diagrams so you can use them and do not get lost. Or you can use it if you have a PCB version, you can use it like that, or maybe put the relay in the negative line and the sensor at the positive line, both of them at the positive line, or if you have this WCS3740, you can use it like that, like this, or in this combination. And if you have this type of sensor, you can put it at the positive, at the negative relay, move the relay. So these are all the combinations, so you cannot make mistake in wiring. And now let's see how we can connect it. This is your load, and you have a battery and you have a sensor. Doesn't matter which sensor you have. You can have this type of sensor without a PCB with a hole through, or you have this shape of sensor that will pass hole through, or maybe a module, something like this, that a 2-wire will be connected here, which I'm going to show you, or this module, or this type with the 2 terminal on the side, or if you have something like this, or something like this. You can put your sensor between the load and the negative terminal where the current will pass through, or you can put it between the positive and the load, or you can put this one between positive and the load, and it will just pass through that. Or you can put it at the negative, the same module here. Or if you have this type of module, you can solder the 2 wires between the negative and the load, or between the positive and the load. And if you have this PCB version, you can connect the 2 wires in this 2 terminal or between the negative and the load. And if you have this shape, you can also connect it between these two terminals, something like this, or between the positive and the load. So you will connect it in series, and we are reading the current through these 3 pins. When connecting the wires, all WCS sensors, they have 3 wires, and the 3 wires are labeled as VDD, ground, and Vout, all of them. So VDD will be connected to 5 volts of Arduino, ground will be connected to ground of Arduino, and the pin that is labeled Vout will be connected to analog 0. And each module has datasheet, and on the datasheet they're all aligned in the same way. So we have VDD, ground, and Vout. So you can get that from the datasheet for each module that you have. For example, this is for WCS 1800. And if you have this type, VDD, ground, and analog out, or for this one as well, the same way, VDD, ground, and analog out, the pins are connected in the same way. This is my power supply, this is a negative, that's a positive, and this is my load. The negative will be connected like that. The positive is coming and passing through my sensor. Doesn't matter which type of sensor you have. Either if you have this type of sensor or these type of modules, doesn't matter. For all of these, you will just connect it and pass through the module, and it comes here, and it comes from here, it comes back to the relay, to the middle pin of the relay, this type of relay. If you're using this low trigger relay, then it will be the middle and the other pin. Pay attention, middle and the other pin. But if you're using this one, it will be middle and the left side, and this will go to my positive of load. So that is done. And for zero current detection, we need to prepare an LED with a resistor. The LED has 2 pins. The longer pin is positive or anode, the shorter pin is cathode, and we need to put a resistor between something like 300 to 1 kilo ohm. The value doesn't matter, because if you put larger value, the intensity of light will be reduced and there is no harm. So we will connect the anode, this longer pin, to the resistor and solder it, and the other pin of the resistor will be connected to 5 volts. In this case, we are going to connect it to pin 2 of Arduino, and the shorter pin is connected to ground. And here is the schematic for the above. So we have 5 volts goes through a resistor and then to diode, to the LED light emitting diode. This is anode, and the side that has line is cathode, and it will be connected to ground. And here for the current sensor, this pin is VCC. It has been connected using green wire to pin 8 here, where we define the pin 8 as VCC for the module. And the second pin is not connected, the blue is not used. The third one is ground. Ground is connected using this purple wire to the ground of Arduino. And the last pin is analog out, the gray, where we read the current, is connected to analog 0. And the LED that I've just shown you, I've prepared, it has been connected to ground and pin 2. And here for the relay, this pin is S, or signal, using orange wire. It has been connected to pin 3 and here. And then we have this, the middle pin is the 5 volts VCC or plus sign. It has been connected to 5 volts of Arduino. And the last pin is negative or ground. It has been connected using this brown wire to ground of Arduino. And if you're using this type of relay, this side is VCC. Using red wire, it has been connected to 5 volts. The middle pin is ground. Ground is connected to the ground. And the last pin is labeled as N, or input, where signal is connected. It has been connected to pin 3, or whatever pin you define in the code. And then for the LCD, this side is ground. Ground is connected using brown wire to this ground of Arduino. The second pin is VCC. This is connected using this red wire to the pin 9, where we define the pin 9 as VCC for the LCD. And then we have 2 pins here, SDA and SCL. I have SDA and SCL. SDA is connected using orange wire to this SDA, and SCL is connected from this last one using yellow wire to this SCL. If you don't want to use it, you can also use this analog 4 and analog 5. Analog 4 is SDA and analog 5 is SCL. First, you need to download the Robojax WCS library. Download it as a zip file, save it in your computer. After that, click on Sketch, Include Library, Add .zip library, and then point it to where you have saved it. If this was inside the download, for example, and then Tutorial, and if this was your zip, select it and click Open. The library will be installed. After that, you have to make sure this of Arduino that you have. So close them all and then reopen. Then go to File, Example, scroll down until you see R, Robojax, and here Robojax WCS Current sensor, and go to Robojax WCS LCD relay, and this will be the code. I'm going to explain the other code. This code is with the LCD, and the one that has no LCD, we just remove the LCD section and it will work. First, you need to select the model that you're using. If you're using, for example, WCS 2801, your model is 2. And if you're using the 1500 WCS 1500, your model is 9. So keep the model number. I'm using WCS 1800 and my model is now 12. This is for LCD. This is a library, Robojax WCS library, and the model that you have will type it here, 12. And the sensor pin that you're reading the current is analog 0. You can change it to any other analog pin. Sensor VCC pin, we're defining a pin to supply power for VCC, that is pin 8. You can change it. And here for the LCD, we need to find out the address for the module. If you're using this 1602, this is the module that has I2C address, and if you're using this larger version 2004, it has this module and it has I2C address, so we have to find out the address. Now for that we have to upload separate code, and I'm connecting it directly to the power supply, not to those digital pins. So it has been connected directly to VCC and 5 volt and SDA and SCL, which I've explained it in the wiring section. So in here, now let's go to File, Example, and go to WCS, Robojax WCS Current sensor, and open I2C scanner, I2C scanners. Do not worry what is inside it, just upload it. If your wiring for LCD is correct, it will be uploaded. And now I'm opening the serial monitor, and you will read the I2C address for the module. It says 0x3f, and it will read it every few seconds. And if you cannot read the number here on the right side on the lower section, it says 9600. Make sure it is 9600. So we get 0x mean hexadecimal and 3f is the actual hex value number. So let's close this and close this. So I've entered here 0x3f. This LCD character is 16 characters. Refers to this 16 characters that we have here, and then 2 means 2 lines. And if you're using this one, it will be 20 characters and 4 lines. So we will enter either 20 here or 16, 2 here or 4, that is number of rows. And then the title, 0 current. And then this title and these titles, these are the 2 titles that are displayed here, current sensor and also current, and the model that you select will be automatically displayed. And we have defined a pin for VCC pin for the LCD. I have defined pin 9, and here shows 0 current true. If you set this to true, the 0 current will be displayed. You see 0 current is displayed. But if you set this to false and upload the code, now the code is being uploaded. And it will not display it. It will measure it, but it will not display it. So it's up to you if you want to eliminate it. I'm just making it true. And here's the current wait time. This is 5 seconds. We need some time to measure the current and also make sure that your load is off and not connected. So this is the time that you wait. You can change it, make it shorter or longer. The correction value, I've explained it in the introduction. measurement iteration 300 measurement. I've explained it. This is the voltage, and these are all the things that I've explained in the main code. So these are all for LCD, and if you are not using LCD, you will not be concerned. You will not see this. I'm going to show you the code quickly. And for the relay pin, we have defined a pin for relay, and this is the current that you don't want to go above it. So the current is set for 12.5 ampere. When the current reaches 12.5, the load will be disconnected. Any current below this will be connected. And here relay type, if your relay is high trigger, put high trigger, and if it is low, put low trigger. This relay is low trigger and this is high trigger. And these are variables, relay on, relay off, will be used inside the code. And this is the whole time, how long you want to wait when the current reaches to this value, for how long you want to keep the system disconnected. And if you want to make it longer or shorter, it's up to you. But if you want to disconnect it forever, stop. If you want to stop it, currently it says false, which means it will not stop. But if you want it to stop indefinitely, just type here true. This is all lowercase. These are defined constants. If you type it in lowercase or mixed up, it will not work. From this library, Robojax WCS, we create an object called sensor, and we pass all the value, the address, the character, the sensor pin, all those values that we define at the top. They will be passed and sent to the library to be used and prepare the code for us. And here we are using this portion because we have a VCC pin for LCD. If you are not using it, then do not use this. It will be a waste of pen. Then use this. How to use it is just right click and remove all this. In Arduino there is a feature in Arduino IDE, right click and then comment, and comment, it will be automatically uncomment, and then make sure to comment this. Right click and then comment. You cannot have uncommented both of these, you will get error. So in my case, because I'm using the VCC pin, I will comment this out and then uncomment this section. And here inside the setup, we define the serial monitor to display the text for us with 9600 baud. So this is a text that is displayed on the screen, and sensor.begin is where we must have it. It initializes the sensor. This will print the model for the sensor. Next line, it prints the version for the library. So if you want to know the version, just at the beginning, if you open it, wait for 5 seconds because it goes with the zero current, and here it shows the sensor and the version. I will update the library from time to time so you know which version you're using. And if you want to print all the models that is supported by the system, uncomment this, it will print all of them for you. We define that using pin mode, a relay pin as an output. This will be setting the pin as an output, whatever pin you have. And here this portion checks if the relay trigger type is high, then we set the relay pin low, so the relay is initially in normal state, off, and then these variable on and off, we set them properly because it's high trigger, so on is high and off is low, and if it is not high trigger, it says else. Here we set the pin, the relay initially high to be turned off, and then for on we set it low, and then for off we set it high. Pay attention, these are the opposite of each other. So this portion will take care of the trigger type of relay. Inside the loop, sensor read current. This must be inside the loop, otherwise the code will not read the current. And then we have 1 second. You can change it if you want to make it faster. And then we have to have relay control. This will control the relay based on the available current. We must have it. These are optional, these two. Print debug. If you remove this, I've explained it in the introduction and in the LCD section. So this will print all the debugging information, and this will print on the serial monitor. If you are not using LCD, then for sure you will uncomment this, and this will continuously, let me upload it, it will continuously print the current on the serial monitor because you will not have a LCD. Right now there is no current. This is for zero current, 5 seconds. and after that it will read the current. So right now this is the current that it is reading every 1 second that I've set it, like that. And inside relay control function, when we run this from the loop, it comes again, it checks if the current is, if you want to do something with the current, this is the current. This will return or get the current for the from the sensor, and you can do something with it. For example, if the current is the current is smaller than 3.5, you want to do something, this is opening here and closing here, do whatever you want in this line. Current is greater or equal to the current that we set at the top of the code, then we set the relay pin on. This on and off changes according to the relay type, and then we print this text on the screen: current reached with this value ampere. So then this is the value, and then we print A, and then we say relay on. And if relay stop is true, then we say here waiting forever, and then while one. This while one mean wait forever. Else, if stop is not set, we just say waiting for this many seconds. So we get the hold for, which we set it for 5 seconds or 6 seconds, 6,000, we divide it by 1,000, so we get second, and then we print the text at the end, this many seconds we will be waiting, and then we apply the same amount of time with a delay, so it will keep the system waiting, and after that it will pass. Now, if the current was above that, the set value, all these action will take place, else again it will go back to turn the relay off using digital write, the relay pin, whatever pin you have connected it, and it will turn it off. Now let's go through the code without the LCD. Go to File, Example, and scroll down to Robojax WCS Current sensor, and then select Robojax WCS Relay. So click that and open it. This will be the code. The difference between the previous code and this one is that we do not use the LCD settings. Nothing is here. We have only relay, and the setting that was for LCD here, it's gone. And we are using one constructor here, and very simple. The rest of the code is exactly the same. Inside the loop we have sensor.printCurrent, which will read the current continuously for us. Let me show you. When I open it, it takes 5 seconds for the zero current reading, and after that it just reads the current like this. Now let me demonstrate it with the LCD, and then I'm going to demonstrate it without the LCD. Now at the moment the current is 0, and you can see the current also on my electronic load shows that it is 0. This relay also will have the light when the current reaches our threshold value. When the current reaches 7.5 ampere, I've set it to 7.5, it will turn on. It will turn on, and this light will turn on. Remember, this relay is 10 ampere, so we will not go above 10 ampere for the test. As I mentioned, if you want higher current, this is 80 ampere or higher, you can find different relay to control different amount of current for current protection. When you boot this up, make sure the load is turned off, and when I press the reset button on the Arduino, you will see here the zero current is now read as 3 ampere. So let's turn it on and off, and so you can see it takes 5 seconds for the zero current to be read, and we will see it here. And now this is the current, and here I'm gonna go with 5 ampere. Now this current is turned on to be 5 ampere, and we are reading it in here. The delay that I set is 1 second, so it reads it after 1 second, and that is this relay. Let's make it 500 milliseconds, and then turn off the load. Make sure the load is off, and this is now when the code is booted, loaded, it will again read the zero current. Make sure the load is not connected. My load is off, so this is now the current, and then let's turn on 5 ampere. So the current is now 7.4, and if I increase it to 8, now the load is disconnected, and as you can see, the current is now 0. Now this is set to hold it for 5 seconds or 6 seconds, and now it will turn on, it allows the code, and it will continuously do the same thing. So perhaps for some applications you do not like this. You might need to set it to be off forever. So what we do is now here on the code here it says stop, and let's set that to true and upload the code. Let me turn off the load. Now this is booting up. Now there is no current, and let's turn on it with 5 ampere again, and I'm going 6 and 7. At 7.5 it will turn on, so now 8. So you will see now this is turned on, it will never turn off. So the load is now disconnected, and it's just holding the last current it was reading, and until you come and reboot Arduino or disconnect the power, this will just stay there. So this is another option that you can check, and maybe you find a fault or something and take action. Now let me demonstrate it. When you boot the Arduino initially, it will read the 0 current and it will turn on. I'm just resetting it by pressing this reset button in here, and wait for 5 seconds so you can read the 0 current. The load is off, and here now we are reading about 70 milliampere even though there is no current. I've set this delay in the loop 300 millisecond. I'm setting the current protection to be 7.5, so it will allow up to this value. System is ready. Around now it's 4.8 ampere here you're reading. Five ampere is read at about 140 milliampere less, and I'm changing it from here, making it 6. So you will see here 6 ampere, and here the current is shown here. Let's go 7, and the current is shown. When it reaches the value 7.5 ampere, as you can see, it was disconnected, and then it is connected back. Now to show you here, it says delay, and here to show you it says current reached, relay turned on, waiting for 6 seconds. So it waits for 6 seconds and again reads it, and immediately it detects it is 7.5, and so it continuously does that. And perhaps this is not a good way to implement overcurrent protection, and we need to set this so it can stop forever. If you want, in that case, to stop it forever, on the code here where it says stop, change this to true. So now stop is true. Let me upload the code. Make sure it is off, because there should not be any current. After a few seconds it reads the 0 current. Now 0 current is read, 3 point something, and this is the current that we are reading. So again let me go 5 ampere, and this is 5 ampere. Let's turn it on. So we are reading the current here, and let me increase it slowly. So 6, now 655, Now it's 7, we are reading 7.49. So as soon as the current reaches, now this is waiting forever. And here at the lower section of the screen, it says current reached 7.5. It was 7.57, so it reached and relay turned on, waiting forever. This relay will not allow any current, and as you can see, the light is on and it will be waiting until somebody comes and attends this and checks why the current is above the value. So to restart this, we must press the reset button here on Arduino, this reset, and make sure the current is off, and then press reset so it can read the 0 current, and it will be ready again. Thank you for watching. This was how to implement the 0 current for Arduino with Winson current sensors. If you like this video and learned something, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, post it at the comment section below. I try to answer and reply. If you want to get updates of my upcoming videos, make sure to subscribe. Let me now demonstrate it. I've connected this larger display, the small is exactly the same. And let's go to 35. I changed it to 35. I'm going now 40. Now this is the current that we are reading, and 50. Just change it to 50. As you can see, it is displaying exactly the same as the other